Hi, welcome everybody. Good to see there's a bit fewer people. My heart rate was already at like 95, so it's good to see. Not quite as many as for Steve's talk. So, just before we get started, we've all been asked to just say thanks to the sponsors, so I just want to do that. Particularly, just want to point out Grey Matter. I've used them myself. They're really good if you need to buy software licenses for anything. So, and again, thanks to Microsoft for just hosting us and all the nice food and all that. Okay, so let's get started. So my name is Franz Lutzen. I'm a CTO of a company called New Orbit. We're based over near Oxford, so not very far from here. And not to bore you with a lot of information about me, but just to give you some context. We're an Azure Gold partner. We build systems on Azure, have been doing that since 2010. We do that for a whole bunch of companies, from enterprises to startups. And as it happens, a lot of the systems we have a lot of personally identifiable information and confidential information in them. So for my sins, I've spent the majority of the last 9 years trying to understand how to secure things in Azure. And if you were there in the early days, you'll know there used to be next to nothing, whereas today there's an absolute plethora of options and features that you can use. So it's been an interesting journey. And today, just to uncover what I'm going to talk about today. Firstly, I'm going to focus on specifically web apps, or using app services in Azure, just because it's the most popular one. There's about 10 different ways to host a web app in Azure, but that's the one most people use. And functions, if you use anybody use functions? Yeah, they're basically the same as web apps under the covers. So everything I say pretty much applies to them in exactly the same way. There are a huge amount of concepts and tools. What I'm going to do is try and give you an overview of it. I'm going to give you a framework you can use and then talk about what tools that I know about that you can use in those different things. But I can't cover everything, and as I said, there's literally individual slides in this deck today that could fill the entire talk. So I'm going to try and give you as much of an overview so you can get an attack plan for how to apply this going forward. Yeah, I've said that already. Now, it's mostly infrastructure and configuration. I have a few code samples that will be in C# just because I happen to use that the most, but you can do all of this in pretty much any language you like, so don't sort of be discouraged by that. All right. So the first thing is before you actually start looking at your security, you need to think about your exposure because not everybody needs the same level of security. Okay, and the security, you can go from paying nothing for security to paying millions, and it really depends on what your exposure is. So you need to ask yourself a few questions like, what would actually happen if your data got out on the internet? How bad would it really be for your business? Is it going to end your business, or is it just going to be embarrassing? And that will have an influence on how much money you're going to spend. So actually have a think about that. And how likely are you to be targeted? So we all know about, if you have a website up there, if you look at the logs, you know you're being routinely scanned all the time by all of these opportunistic drive-by attackers, and that's one level of exposure. But if you have a system that is known to be vulnerable, then you might be directly targeted, and that kicks in another whole level of concern. Like, the best way of getting into a system is to go and drop a corrupted USB stick in the car park outside your offices. And then so you have to start thinking about those kind of attack vectors if people are likely to attack you. So it isn't just enough to think about, what you can do up in the cloud and all of that stuff. There's a lot more to it. And when your CTO comes and tells you that it needs to be 100% secure, well, that doesn't exist. There's a story, which we can't know if it's true, but GCHQ wanted to get into a Belgian bank to find some data. The way they did that, apparently, was they broke into one of the bank employees' flat and hacked his laptop while he was out. So if somebody wants to get into your system bad enough, they will get in. So you just got to think about, again, where do you put the line and how much are you going to protect this stuff. But if it is a state actor, you're pretty screwed. Especially if it's the US government, because they have the Patriot Act, which means they can tell Microsoft to give them your data no matter where it is in the world and not tell you. If you have that problem, by the way, Azure in Germany are not owned by Microsoft for this particular reason, so that's where you put your data if you have that particular problem. Just a little side tip for you there. All right. So the best way of thinking about security is to try and divide it into 3 layers. So the first one is the one everybody likes to talk about. Let's prevent people getting in the first place. And that's nice and it's sexy and it's technology and we can do fancy things and stuff. Albeit there's a very boring side as well to that, which is internal actors, because it's great that you can get these bad hackers out over in whatever, hacking into your system and worrying about that. But what about Bob in accounting who's just trying to be nice and, you know, looking at some data that you shouldn't look at? You've got to think about that too. Okay, and I'll come on to that in the next slide. The next thing is, all of you guys here, and ladies, sorry, all of you people here, I should say, sorry, I'm trying to learn. How do you know your system isn't being hacked right now? What level of confidence have you got that right now an attacker isn't trying to get in? How sure are you that your data hasn't already been hacked and is on the dark web right now? How do you know? And that's the thing where most people fall down. That's why, you know, you get these stories about these companies coming out and saying, oh, we got hacked 2 years ago. We just found out. And you think, why is that? But actually think about your systems and you tell me how many of you can be sure that you weren't hacked 2 years ago. And that's one of the problems. So you've got to pay a lot of attention to detecting attacks so you can do something about it. And then the final bit, there's this mindset called assume breach. I don't know if anybody heard that one before? There we go. So the assume breach means you should always assume that an attacker is already inside your system. Now, what are you going to do about that? How do you mitigate the impact of that? What can you do to make sure that even though they are in, you haven't stopped them, they've gone through all of the hurdles, you might not even have detected them. What are you going to do to reduce the impact of them being in there? And that's to mitigate. So you've got to think about all of those things. It isn't enough just to think about how can I do some fancy piece of cyber hardware that fixes all my problems. It just doesn't work like that. So I hate standing behind a lectern up here and being tied to these microphones. So this quite boring table, I'm just going to go through these things because this is the kind of things you need to think about. So on the prevent, the one we all know about, make sure you secure your code. I'm not going to tell you how to do that. That's not what this talk is about. This is about Azure and the things that come with it. What you need to do, if you haven't already, go and watch Troy Hunt's courses. Go and listen to Robin's talks about you know, using the tools for that, and make sure your code itself is secure. But that literally is 101. That's the very first thing you need to do. If you don't do that first. But then its next thing is locking down your servers and using firewalls and making sure that you encrypt everything. I'm going to talk about that today, to talk about some of the tools you have available for that purpose today. Then think about your internal actors. So your person in accounting. I'll give you an example. A customer of mine has enough data to steal the identities of 2 million people in the UK in a database that we host on Azure for them. Quite paranoid about that, as you can probably imagine. They had a very helpful person in their support team who decided he could figure out a better way of running their business processes, but he didn't have time to do it at work. So he downloaded lots of this personal data and emailed it to his Hotmail account so he could work on it at home. He wasn't being bad. He wasn't being bad. He was trying to be nice. He was trying to do the right thing. He did get a P45 out of it, though. But that's the kind of problems you're dealing with in the real world. And you've got to think about how do you stop that. And the education is part of it, but humans are humans, and humans want to help. And if you go and ask any hacker, the way they get in is not through the front door. They go and they call up somebody and saying, hi, you know, yeah, I need to change. I forgot my password. It's because I got married. I've been on honeymoon, and it's been so long, and I got a new name, because I got a new email address. And can you just change my email address and my password? And yay, and in we are, right? That's the real world. That's how it happens. So you've got to think about all of those things as well. And then things like just practical terms. Going to mention that using Azure AD for your internal users, so you don't forget to lock their accounts when they leave. You know that thing when a developer leaves and have the database password to the live database? Do you really remember to change it? You know, those things. Again, I'll show you some ways of handling that today, because it doesn't have to be as hard as it used to be. Detecting. So I'll show you a number of tools that Azure has, or talk about a number of tools, but you also need to start thinking about how do I know somebody's doing something bad? And you can set up, there's automated alert. Azure has some amazing tools. But you can do manual things as well. Like, you know, if somebody is trying to do a privilege escalation attack, you know, that's the one where they are a known user, but they're trying to do something they're not allowed to do. You'll start seeing a lot of 403s in your logs if you start, you know. So have an alert set up for that. If you get more 403s than normal, somebody's probably doing something bad. If people are trying to scan you for vulnerabilities, you know those things in the logs about that says /WP/admin, those ones? So when you start getting those lots of 404s in your logs all of a sudden, somebody might be up to something dodgy. Look at what the normal level is, set an alert for something a bit higher so you know. Failed logins. Okay, so again, I look at my systems, I know this particular system, normally I get 20 failed logins an hour. Set an alert for 50 failed logins an hour, and then at least you know somebody might be trying to guess a password. Just simple things like that. Well, you can't be guaranteed to know somebody's trying to hack you, but you at least have a fighting chance, okay? And then there's a bunch of tools like advanced threat protection and so on and so on. And logging, alerting, blah, 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 DLP, etc. Mitigation is mainly, there's two things you can do. For most normal scenarios, this is mainly about encryption, and you can encrypt at different levels, and I'll come on to that in a minute. But if you have really sensitive systems, there are certain architectural patterns you can employ to make your system more secure by design, like having a separate service that deals with the database, because then even if your hackers get a bridgehead onto your web server, then they have to hack another server before they get to the database. Things like splitting data across multiple databases, so you have the PII in one data and the sensitive data in another database, and then rotating the keys for them and all that kind of stuff. So if you have that scenario, you probably know how to do that, but if you are coming into that kind of scenario and you don't know them, ask somebody who, seek some help and get those patterns in place as well. Because technology, those other tools aren't going to do everything for you. If people are already inside, how are you going to stop them getting too much useful data? Okay, enough of that. So yeah, this is what we're going to cover today. Just all of those blobs there, yeah? That's sort of the ideal thing. That's the one with all of the bells and whistles and all the boxes ticked. So I'm going to take you through this one. So this is sort of your Azure setup in an ideal world. So I'm going to go through these in the following. So this is all primarily about prevent and a little bit of detect and mitigate. So I'm going to go through getting in, secret management, network isolation, and so on, as it says on the screen. So the first question I always get is, oh, can't I, how do I make sure that people can't get in? That's the first thing, right? And that's what we all worry about. How can I stop the attacker from hacking my website and getting into the system? And usually people think there's some kind of magic bullet. There really isn't. I'm going to give you the tools that you can and can't have. And just to forewarn you, it's not all roses. Azure is still not quite there yet, but I'll tell you what you can and can't do. So the first thing, just remind you again, make your code secure first, okay? Go and watch those Troy Hunt courses, get a pen tester on the code, make sure the code at least is okay. Okay, because that really is the biggest thing. It just isn't enough. And then the next thing people always say is, oh, can I stick a firewall on this thing? Yeah, because firewalls are great and they solve all my problems. The short answer on Azure, no, you can't. Not if you're using an app service, the normal app service, you can't stick a firewall in front. And it looks sort of like you can, but you actually can't. And the reason you can't is because you can't have a web app being controlled by a virtual network with a firewall in front that then uses that virtual network. It just isn't feasible. It just isn't possible. What you can do, you can only do that for internal microservices. You can log them down in that way, but not with a firewall in the play. You can do something called a WAF, Web Application Firewall. Have anybody heard of those? Yeah, anybody like them? No, they are a stupid invention. That they really are. Avoid them if you can. If you must put them in, yes, you can. I would advise you not to use Azure's one, because unless they've improved it, we tried using it and it is horrible and has huge performance issues. I mean, that was a year and a half ago. They might have fixed it since, but at least back then we had a site was 3 times slower and 10 times slower for about 10 minutes every morning. So it might be better now. But back then it certainly wasn't. If you must have one, have a look around and find some people whose only job it is to do WAFs, because they're not easy to make. Oh, and also we also had regressions where that happened 2 months ago, where they applied a new rule set overnight on a site that was still using it, and bang, our site died, because there's no need to tell me that they're changing the rule sets overnight, right? So yeah, just don't use that one. If you have what's called an app service environment, you can have the firewalls, and you probably should. because then you are not given Microsoft's own firewall, the standard one. App service environments cost a fortune, mind you, but if you have that, then you do need to put a firewall on yourself. Okay? So the short answer, as I said, is Azure actually does give you a firewall. It does give you some level of intrusion detection and intrusion prevention. They're just fairly permissive, so they're not going to stop everything for you. That's just a choice you're making. And if you're in a highly regulated environment, you might need to do something else where you do it in a different way. But that's what you get out of the box. TLS and SSL, this is an annoyingly long slide because it should be a tick box in Azure to just say, make SSL happen magic, right? And it just isn't, unfortunately. So a few things. You need to tick that box in your web app that says always use HTTPS. But if you do, just be mindful that that might break the always on tick box. And they might have fixed it since I last checked it, but it used to be, at least it might still be, that always on doesn't understand SSL, so you tick always SSL, and then your always on does a request on port 80, gets redirected to port 443 and says, I don't know what that means, and stops calling you, and therefore your website doesn't stay warm. They may have fixed that since, but it certainly didn't used to work. For SSL certificates, you can buy certificates, you can upload them yourself, or you can use Let's Encrypt, which is a little plugin you install, and then that will automatically get you free certificates, auto-renew them, and that's great. Unfortunately, and I do use it, but it does require that particular Azure website plugin does require you to take essentially administrator passwords and putting them into config. So it's basically the password for your administrator for that website, and probably the subscription. That username and password is now available to anybody who can read the config of that website. So, yeah, but it's free, so, yeah. Azure App Service certificates, they do the magic for you. There is a tick box. They're not particularly cheap. You are looking at easily 300 quid a year for SSL certificates on a website using that service. But it is very good, and if it is a production site and you haven't already got experience of any of the other ways of doing it, that's probably 300 quid well spent. So, that just takes the problem away. Or finally, almost finally, Azure CDN. Anybody use Azure CDN? Yeah, that's good. So that gives you free SSL certificates. So if it's feasible for you to take a CDN in front of your website, and if that's like only a couple of quid a month, depending on traffic volumes, then you can actually get free SSL certificates that way. So you can start doing stuff with that. So that's one of the options. I haven't used that one myself, but it is a possibility. And then finally, this is really important. You need to remember that when you're talking to your databases and your blob storage and your table storage and everything else, you need to make sure that you use a TLS on those connections as well. And it's usually just remembering to put that extra S in the connection string. But forget at your peril, because if you don't do that, there's a risk that somebody else on Azure can eavesdrop on your traffic. And then you've done all of this great stuff to protecting it coming in, and then somebody else can potentially sniff it. It's hard to do, but GCHQ and the NSA have been known to do this. There is a reason why Google and Microsoft and all the other guys a few years ago decided to encrypt all of their intra-data center traffic. It was a direct response to spy agencies trying to get in. So again, depending on your exposure profile and all of that stuff, it's just something to be mindful of. Most of the things can be set up now to require, so databases and blob storage and all of that it's not enabled by default, but most of them can be set up to require TLS connections, similar to what you do on the website, and I strongly encourage you to tick that box, just to make sure. Okay. So on this, there's the thing about logging in. So we have all, I think we've all written our own login screens, or used web forms logins and VMC login forms and cookies and all of that kind of stuff, and that's great. But these days, most people don't write their own login logic anymore. You tend to outsource it. So there's a number of providers. Zero, for example, do a fantastic service that do just a million things for you. Azure has their AAD B2C, which is pretty good. It's not ideal, but it is pretty good, and it's very nicely integrated into Azure. We use it a lot, simply for compliance reasons, because my problem is with my clients, it's like, okay, your data is in Azure, and your passwords are with Auth0. It's like, I don't want to have that conversation, so I use AAD B2C primarily for that reason. It's just it saves me a conversation. And you tell enterprise clients it's Microsoft who handles the passwords, and they tend to be quite happy. It just solves that problem. So I strongly recommend ADB2C authentication and AAD. So if you or your office or your clients use Office 365, then you can also use basically your Azure AD. So Office 365 logins is Azure AD logins, just for terminology's sake, to clarify that. So you can use that to just log in. That can be as simple as a tick box, and I'll show you that. And it can also be really powerful with functions as well. And I'll explain that in a minute. So you have multi-factor authentication. Now with the Azure AD, i.e. Office 365, that's a really good multi-factor authentication. With Azure AD B2C, it's text message only. So again, which is hackable as well, as you know, because text messages can be faked, right? And intercepted. Did you know that apparently in Washington is the place in the world with most fake mobile base stations? I mean, you could build your own mobile base station, right? That pretends to be a base station and picks up phone signals to intercept text messages. There's more in Washington than anywhere else in the world of fake ones. Well, for obvious reasons, obviously, but yeah. That's why when the president drives around, they basically have something that jams on most of that stuff. So, anyway. Yeah, crazy world, isn't it? One of the nice things about, and we've used this, is with Azure AD B2C and Azure AD, you can use that to provide OAuth tokens. So if you have like a function app and you want your consumer of that to use OAuth tokens for that API, you can actually let Azure AD B2C handle the entire thing. There's a tick box you can tick. It will effectively put a proxy in front of your function app that handles all of the OAuth termination and also normal logins as well. It will redirect you over to a login screen and just do it. And your application, in fact, that's on the next slide, will just get, if you tick that box, your application just get a header with here's the user. And that works for both interactive logins and for, and as I said, for OAuth tokens and APIs. So that's really useful. And it works really well in relatively simple scenarios. So we use it in a couple of setups where we don't have a lot of complexity with it, and it is quick, especially for internal applications. If you're doing stuff just for your own business and you have Office 365, it is literally a tick box, and then that application is secured, and and you even get the user coming up in the controller.user if you're using MVC, that kind of stuff. Very, very easy. Or you can handle it in code yourself, which we mostly do when it's anything slightly complicated. But it's when you handle it in code, it's a bit painful to get your head around, and some of the defaults aren't particularly great. But once you get over that, it's a few days, and then it's up and running. So, you're frowning, Pete. Is it more than a few days? Sorry. Yeah, that's that, isn't it? What is it? Control panel, dial up user competence. That one. Yeah. All right. Good stuff. Okay, secret management. So one of the biggest problems we've always had is we have the password, I mentioned it before, that's the database password. And who has the database password? And if you have it, then you have access to everything. And not only have you got access, you also I can't know that it was you and not the application that did the thing. I have no auditability. Now, it's probably worth just mentioning, if you're working with security, there's security, and then there's security compliance. And some people think they're the same thing, and they really aren't. Sometimes compliance makes security worse. But at best, and sometimes it makes it better, sometimes it makes it worse, and sometimes it's just stuff you have to do to go through certain hoops. But one of the big things in compliance, and rightfully so, is auditing. You need to know who logged in, who did that change, who was it who looked at that data, who was it who deleted that. That's a big part of compliance. That's really hard when everybody's running around with the master database password and all logging in as that user and doing stuff. Because you have absolutely no idea, and you would never pass any kind of security audit if that's the case. But when the password is right there in the connection string, hey, it might even be in the data in the source code. Credential in source code, anyone? No? Okay. Anyway, so that's one of the big things. So what you need to be able to achieve is that those credentials, you need to not have them stored anywhere where anybody can get at them. And that used to be, until 18 months ago, was a nearly impossible problem to solve, because there always was a password somewhere, short of a few really weird hoops you could jump through. But there's an answer to that now that is absolutely magic. And if you can get excited about security, get excited about that. And then there's this thing called service principles, which I'll explain in a minute, but the general idea is that you should not use those usernames and passwords. You should use these special users that act on behalf of your application to get into stuff. And I'll go through what that means, but that really is sort of a best practice kind of thing. And then this managed identity, that's the magic, and I'll explain that too. So that's what you want to achieve. Now, how many people here knows what a service principal is? So it's a few people, okay. It's a really complicated word for just meaning it's an application user. It's just a user that is an application, not a human being. That's literally all it is, okay? It's in Azure AD, you create them and you say, oh, that's my web application. And they sit in the Active Directory as another user. You can give them roles, you can give them permissions, you can audit them, just like you could any other user. There's nothing magical about them other than they have a fancy name and an extremely weird way of creating them. If you need to create a service principal manually, it involves going into Azure and saying, I want to create a web app that has a URL that doesn't exist because it's a console app you're writing. And you want the console app it's a console app, right? But you have to create a web app with a URL that doesn't exist. Just don't try and fight it. Just embrace it and go with it, and you'll have something nice, okay? Often, though, you don't actually have to create the service principal yourself, and that's the magic. So what Microsoft introduced a while ago is this concept of a managed identity, and this is really magic, especially when we get onto the next slide, and you can see how you can really use it. Because the problem was always, well, there's got to be a password somewhere, and I do remember a few years ago trying to create a service principal and then create a certificate and then upload the certificate into the web app in a way that couldn't be downloaded, and then have the service principal logging in with the certificate and then deleting it from my machine, and then hopefully that was secure. But I never rolled it out because it was so convoluted and hard to do that I just gave up. But it was possible. Managed identity, you go into your web app settings. Here, let me see if I can point to it. I can't, that doesn't work on the big screen. Okay. You basically just go and tick that to on. What Microsoft will do for you, they will go into your AD, they will create a user, and they will make that user only accessible from your web app. What they do in practice is they put a little REST endpoint on your local VM that can only be accessed from localhost, and you can call that, and you basically get an authentication token that is valid for that user. That user has no password anywhere. There's no password to leak. There's no way at all for any human being to log in as that user. It can only be used from that server. That's magic. Because then you take that user and you use that to access everything else. And the line of code in C#, oh, don't go that close to the microphones, is that line there, new Azure Service Token Provider. That's the amount of code you have to write to get access to that. And even better, when you're running locally, as long as your domain joined to Azure AD, it will magically just use your local login, your local Azure AD account to be you. That's magic. Especially when you combine it with Azure Key Vault, because I remember Azure Key Vault when it came out, and I was like, that's great, I'm going to put my passwords over here in that thing instead, and then nobody can see them except I need the password to log into Key Vault, and then I have to put that password somewhere, and then, oh yeah, right, nothing works, right? With Managed Identity, you give Managed Identity access to the Azure Key Vault, and that means now only your application can read the secrets. You can even set up Azure Key Vault so that you can give individuals write-only access. So if you have a secret, you can give it to somebody and say, you are allowed to write the new password into the thing, but you can't read it. And then you really are, locking it down as much as you possibly can. Once it's been written in there, it can never be retrieved by anything other than your app, unless you change the permissions, of course, but then that's audited in other ways, and you can set alerts on that as well. Does that all make sense so far? Yes, you can, yeah.
So this has an equivalent in PowerShell, this C#?
I don't know. It would be in the web app config. So if the CLI or the PowerShell script to configure the web app has that, then that's how you would do it. And you have to divide. If you do need to create a service principal, it's worth doing it through PowerShell. It's somewhat less painful, or at least less confusing, because it at least talks about service principals rather than apps, right? That you have to divide. So that's how you do that. And also it works for VMs and web apps and a few other things as well. So it's not just web apps, and they're doing it more and more. Anybody has heard of Key Vault before or used it before? Yeah, pretty cool technology. Part of the problem is it does too much, and it's like I'm still trying to figure out all of the things you can do. But yeah, so that's it. So that's how you do it. That's how you store your secrets. That's how you get them out of config, out of where people can read them, and that's how you stop worrying about your lead developer just left and he has the database password, and now I have to change it. That means I have to take the site down. That problem's just gone away. Okay, it doesn't exist anymore. And when you get audited, you get a nice pat on the head from the auditor, and they say, "Good job." So that's always nice. Okay, and then just to show you how to use it in code, this is C# again. Then it's basically, this is the amount of code you have to write to retrieve the stuff, again using managed identity. It is that simple. You just pass in the token provider and the Key Vault client, and that's it. How many is an ASP.NET Core? Yeah, so if you're an ASP.NET Core, you can do this. It's literally just that add Azure Key Vault line right down there in the bottom on the right. What that will do is it will automatically go to your Key Vault, take all of the secrets you have listed, and pop them into your iConfig object. Job done. That's just dead easy. And then there's just no hassle in putting it into Key Vault from there. It's daunting. We have many systems where we haven't set it up yet because it feels scary, but actually it isn't. It is really dead easy. You just got to do it. Okay. Now, the next thing you can do, that's also very cool, you can connect to your SQL using managed identity. So you can actually completely let go of the whole idea of having a database password for your app in the first place. So what you got to do is you create that managed identity user before by flicking that thing over to on, and then you have to go into your SQL database and you have to add that user with the appropriate rights. That is way harder than it should be. And every time I talk to the SQL security team, I tell them that is too hard, but one day, because they're all SQL wizards. For them, it's easy, right? For us mere humans, it's just hard. Sorry.
So one question about the managed identity for SQL servers. Is it not like in the pre-Azure days, you had Windows authentication for SQL servers?
That's right.
You would never think of using a username password, if you remember.
That's right.
So I was assuming that this would be as simple as that. Like,
yes.
You have your AD, you just tell SQL
That's it.
that this is my username password.
That's exactly right. Well, except it's not the username and password. It's just the authentication token. But yes, that's right.
But you think it's still difficult?
If you are a SQL admin, it's really easy. It just means to do it properly. Last line. To do it properly, what you need to do is you need to log into a T-SQL thing, and you need to do the create user thing, and then you do as external with the thing, and then you have to add them to the right groups and add them to master. I said if you do SQL if you are into that, then it is really, really easy. I just don't. I mean, for the last 10 years I've used Azure, and therefore I've never had to do that until we started doing this. So for me it's hard. But if you know your SQL, honestly, it's 30 seconds to do it the right way. So yeah, it just depends on where you're coming from. The shortcut, if you just want to try it real quick, is that in Azure you can, there's something called, because you can make any AD user a user of your database, including a security group. So you can create a security group and you can make that the SQL administrator in Azure. It's called the, you go to the server, not the database, by the way. Every single time I do it, I go to the database and I spend 5 minutes swearing that I can't find it. And it's on the server. Go up there, select the server, and then anybody in that security group can access the database with full admin rights. Now, you don't want your app to have admin rights to the database, okay? That's why it's not a good idea to do for production, but it's a very, very quick way of just making this work. Okay. And then in your code, it's as simple as that. If you're on .NET 4.6 or .NET Core App 2.2, which means not .NET Standard, because that's not, can't be, it has to be .NET Core App, then it's literally just that. You have to remove username and password, and then you just add those lines of code, and that basically just tells the SQL connection to go and talk to the Azure token provider, get the auth token from that local REST endpoint, and append that to the SQL connection, and boom. So a lot of stuff happening under those 2 lines of code there, but it's quite magic.
So in connection string, we don't need to provide credentials?
Correct. You take the username and password out of the connection string completely. And this thing will basically just attach that token to it. And that's, again, quite powerful, because that, again, it can't leak then. You don't have to, and you don't even have to put your connection string in Key Vault anymore. Just stick it in normal config, because it's not sensitive, right? Nice and easy. Cool. The next thing, and this is the one where, so all of this stuff up front, that's just essentially about how to manage your secrets and those kind of sensible, just good stuff. Now, the thing that most people talk about is network isolation and the story behind that, and that's all about how can I stop people listening in, and that's where auditors tend to get quite, they want to know how you do that kind of stuff. And again, there are some good and bad news on this one. So you can do some really clever stuff, and I'm going to explain this, and I really like this. I really strongly recommend it. This is best practice, what I'm about to explain. But right now, there's a preview version of this, and there's a not preview version, and it only works with preview. And preview has some other limitations, like, for example, if you like to host more than one web app on the same app service, at least last time I looked, only one of them can be connected to a preview VNet, stuff like that, whereas on the full one, lots of them can use it and stuff like that. So I'm expecting all of that to go away, but just be mindful that you might run into some limitations, and the reason I'm not listing them out here is because they tend to change as they update in the preview, albeit it has been in preview for over a year now, so we'll see. Right, so the idea is that you create a virtual network that your web app is allowed to talk to, and then you tell your database and your storage and your Cosmos and your Key Vault and all of those other things, even your other microservices and your other functions that don't need to have a public face, you tell them you can only be accessed through that VNet. And that's really powerful, because I think we've all looked at the firewall settings in SQL Azure, and it's like, oh, it's great. It's like, I've got a firewall, and I've got these IP addresses, and nobody can access them, but there's this big thing in the top that says allow access from Azure services. So if I want to start hacking your SQL server, I just spin a VM up, and boom, I'm inside the firewall, right? It's almost pointless, that firewall in Azure. Okay? So yeah, so this is why you do it this way, because then it's all completely closed off and nobody can access it other than you. So what you need to do is you create a virtual network and a subnet. Again, I won't take you through it because, again, I'm condensing this stuff. It's not terribly complicated in the new way of doing it. You just create a virtual network and a subnet, just call them the same thing. You only need one. You don't need multiple subnets or any of that clever stuff. Just repeat the name twice and off you go. Then you add service endpoints. It's basically, you say, if you want to access SQL through it, you have to go in and tell it SQL can be accessed through this. If you want to access Cosmos, you need to add that. And you just tick all the boxes for all of the service you want to be able to access through this VNet. And that has a lot to do with just a whole bunch of internal magic that then happens, including, it's actually really quite interesting in terms of how complicated that is, because apart from anything else, Azure will also start messing around with the DNS settings for this. So that's where you get a performance benefit out of this as well. Because when you are accessing, say, your Azure SQL database from your web app, you are using a public DNS, and that resolves to a public IP address. And what actually happens is your web app, it goes all the way outside the firewall and back into the Azure firewall to get to your database. And that's another few network hops and stateful inspection and other stuff going on there, every single database call. You do this, Azure rewires the entire DNS thing, and your IP address, so that same server name that you have in your connection string resolves to a different IP address now, which is the internal one, and you're bypassing all of that. So you're saving quite a lot of network hops on your thing. So you get some performance benefit as well. Okay, right, so the next thing, I'll show you how to do that. You restrict the access to the service, blah, 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 I told you that, and blah, blah, blah. Now, I mentioned that, cool. One thing that really caught me out when I was doing this, it's supposed to be instant. And then sometimes you do this thing, and okay, set this thing up, and then nothing works, and nothing talks to each other, and you're like, I'm going to get a cup of coffee, and you come back and it all works. So just bear that in mind, okay? It sometimes takes some time, so just be patient. It's not supposed to. The documentation literally says it's instant. It isn't always.
Same applies to service principal as well sometimes.
Yeah, exactly. So yeah, and but it's really scary when you're like, I've just switched it all off and now it's like nothing works. You know, it might be DNS resolution. I don't know what it is, but there's certainly things going on. Now, in SQL Server, the way you do it is you I'll go over here because my pointer doesn't work. That's very annoying. So yeah, you basically switch the thing off. Super scary. Because then how much is going to break? And then you add the virtual network down here. You just add it, select it, and that's it. Boom. Easy, easy peasy. Now, importantly, you can still open up your firewall. So when you have that problem about, I need to access this from my local network to do Power BI reports or whatever, you can still add IP addresses to that. Albeit there's a better way, but it's not in the slides because I literally learned about it on a call like 2 days ago. There's something new called private link that's in preview, which allows you to set up a VPN from your local network and then access SQL Server through that. It used to be you couldn't do it. We spent like 2 weeks trying to make it work with the virtual network because it looked like it should be possible, but until we asked somebody and they said, no, you can't. Actually, that was the third person we asked at Microsoft to say we can't. The first two said we could, but anyway. But yeah, the private link will do that. So if you need that as well, you don't have to open up the firewall anymore. Just use that thing with virtual networks as well. So that's that. That's good to know, hopefully. And then finally on the web app, you go in and press that preview button and add the VNet. You select the VNet and, sorry, wrong button. And you just select the network from the drop-down, and that's it. Now your web app talks to your database through the VNet and not through the public IP addresses. It really is that simple. It's just scary. Hi.
What about the backup services? Because we were told you have to turn the allow access for Azure on to make backup able to talk to it.
You're probably right. I don't know. This is the thing. They haven't quite got all of this done yet. I worry about app.powerbi.com as well, because I don't know how to give that access, because I don't know whether it has stable IP addresses. So yeah, there are issues with this. It's not perfect yet. I know they're working on better tooling. They're working on better monitoring tools to let you see what's going on and where you're being accessed from, that kind of stuff. But don't expect that until sometime late next year. But, you know, we're going in a direction. What I mean, this is one of those where I'm not inclined to use VNets on most of my databases today because of that. But if I have a system where the auditors are heavy on me or where the security level is up there, I will switch them on. So it's sort of, you got to choose your poison, right? It's a compromise. It's not perfect yet. So yeah, good question. Thank you. There's another option. You can use IP restrictions instead. So what you can do is you can go into your web app and you can find all of these outbound IP addresses. And then you can go onto your database or whatever and add all of those to the firewall rules and switch off Azure Access, and then that will work. Now, it's not ideal. It can be better than nothing because they can change, and these are shared. I mean, there's hundreds of web apps behind the same IP address as you have. As we found out to our detriment when we got blacklisted by an API in Geneva for hitting them too hard, and it was actually somebody else on the same Azure IP address hitting them. So that was fun. Yeah, so you can do that. And then that's a cheap version. I don't recommend it, but it might be one of those ways to get past an audit. You know, if you have to try and do a bit of a squeeze it through kind of thing. Oh yeah, that was it. And then you just do that. On the other side, you add the firewall rule. Talked about that. Fine, no worries. Encryption, 4 minutes behind. Okay. I love encryption, by the way. I'm a super geek when it comes to this stuff. I think it's amazing. But so forgive me for getting excited about this stuff. Okay, firstly, transport encryption. So there are 3 layers. People talk about, oh, encryption is just encrypted, isn't it? And it's like, well, yeah, but what do you mean? So the first one is transport encryption. You've got to make sure that you use TLS. We talked about that before. So SSL certificates all the way around, blah, blah, blah. Make sure you do that. That is really 101. And it's on by default. Encryption at rest is now, it did not used to be on in Azure anywhere because it's pointless. but now it is on everywhere. So your database is encrypted at rest. It goes for SQL, it goes for Cosmos, it goes for storage. It's all encrypted at rest by default. It is entirely pointless because it helps if either somebody can go in and take your hard drive out of a rack, and I think I went on a tour of an Azure data center, and they proudly told me they have 400,000 hard drives. None of them are labeled, and the people who know what's on which drive is not allowed within 300 miles of the data center. But, you know, it's a requirement. Or people who can log onto a server and see it, but these are not server things, and everything is striped. So your database is probably spread across 10 different physical disks in that data center. Good luck, okay? But the compliance guys asks you, yes, it's encrypted at rest. It just doesn't help you in any way, shape, or form. Application layer encryption, however, that is very powerful, and there's some really, really cool tools in Azure now that you can use. And not only in Azure, actually, some of these work on-prem as well. Basically, you can let the application encrypt some data before it goes into blob storage or table storage or SQL database, and then so that even if I have access to any of those things, all I see is nonsense. But the application will transparently encrypt and decrypt that for you. So in your code, you don't know it's encrypted. It just looks completely normal. Okay? So I'm going to go through this. By the way, the reason I don't show any of this in the Azure portal is because everything takes a long time. So that's why I do screenshots of these things instead to take you through how it works. So let me show. Oh yeah, I did mention .NET Coax support is coming. Again, I'm not quite sure where it's at the moment. I did try and find out, but it's gone very, very quiet. But fingers crossed. It certainly wasn't in any of the 2s. It's supposed to be coming in 3. So, blobs, tables, and queues. So essentially, it uses Azure Key Vault. And you just tell it. You basically just tell your connection to storage that you want to use. Encryption, and you point it to a key vault, and it does it all automatically. It is smart in that it uses automatic key rotation, and as long as you use managed identity to access the key vault, you have now ensured that only your application can access this data. Okay, and because the secret-type key vault, you're not going to. There's something called cryptographic lockout, where you basically lock yourself out of your data by encrypting it and then losing the key. Because the key is in Key Vault, that can't happen, because all you have to do is change the permissions on the Key Vault, and then you can get the data out. So that's quite handy. So we actually wrote our own implementation for this before this came out, and encrypted millions of documents with it. And ever since, I've lived in dread fear of losing that key. You know, it's scary. Anyway, but you don't have that fear anymore. And it's it does the classic thing about every single blob, for example, will get its own symmetric key that gets encrypted. That then gets encrypted with a public key, and those public keys rotate, so there's multiple of them and stuff. And it's basically all best practice all the way around. If you're into encryption, it's worth looking at the implementation because it is really cool. But as a consumer, all you see is that in your application, you go clear data, you go and look in blob storage or table storage, it's garbage. It's that simple. We use it quite a lot now because it's so easy to switch on. SQL Always Encrypted is very, very clever. So the way that works is that you start by going in, and this works on-prem as well. So you start by going into your SQL Enterprise Manager, and you go into, there's a little task that says encrypt columns. And then what you do is you select the thing, and you select how you want to encrypt it. Sorry if you can't read that. But I have a table called flowers, and I've said that I want to encrypt the name column because I'm not going to search on the name column. Now, you've got to bear in mind there's a couple of things to just talk about here. Firstly, if you encrypt a column, then of course SQL can't read it either. It's your application that encrypts it, it's not SQL. So if you go and ask the database, oh, can you please give me all of these flowers sorted by name? It's just going to go, meh. Because you can't do that, right? Now, you can, if you choose, so there's 2 different types, either random or I think it's symmetric. If you choose random, you also can't do a where clause. You can't say, give me all of the flowers where the name is Lily. However, if you do use symmetric, you can, because symmetric basically means that every time you encrypt the same string, you get the same result. That is less safe from a cryptographic point of view, but it means you can do where clauses on the strings. Only for the whole string, not part of it, not like or anything like that, but you can at least search on it. So you've got to, make some choices there. about what you're doing. So when your CTO or your customer says, just encrypt it all, it's like, well, no, I can't do that, because then everything is a table scan and I have to load all my data into memory all the time. Thank you. That's perfect. I'm actually perfectly on time, that's good. Almost. SQL, so you do that, and then basically that's what you get after you've done. And you point to a key vault, and then it will go and talk to key vault, set the whole thing up, and then that's what you now start getting. I think that's it. That's just pansy in the real world. Anyway, and then in your code, so what you have to do to set it up, this caught me out, so remember this, okay? You need to give your managed identity access to create, get, list, sign, verify, wrap key, and unwrap key. All of those things it needs, all 6. Any one of them missing, and it will just break in subtle ways, and you won't understand what's going on. You need to change your connection string to tell it that you're going to do this, and then you need to add that little bit of code. And again, just to prove I'm an idiot, it took me like half an hour to figure out that call to register column encryption keys is a static call, and you just have to call it once. I kept looking for how to figure out how to get it called at instantiation time. You just call it at startup and you're done, okay? So hopefully, if any of you are as stupid as me, that should have saved you a little bit of time. Now, detection. So that's the last piece. So how do you know somebody's breaking in? And this is where I have to say, the tools you get out of the box in Azure are absolutely amazing. I've been fairly critical of a bunch of other things to do, but here they absolutely shine. And when I've been audited, the auditors are always completely in awe at how amazing this is. I cannot stress that enough. So you just got to switch it on, right? Automated alerts is the first thing. So what Microsoft will do, there's a number of tools I'm going to mention. They use machine learning to automatically baseline your application to find out what's normal. And then they start telling you when things are not normal. So for example, this one here, application insights, you just switch it on, point it to your application, and it will start finding out how often you get an error, how often things go wrong, how much CPU you normally use, how much memory you normally use, how many outbound calls you do, how many inbound calls you do. All of those things it baselines. And then after a few days, when any of those change substantially, they email you and tell you. And this is a real life example. You know, something was normally 0.4 of requests failed, and all of a sudden 7%. Now they're not doing this for security. They're doing this because it's great to know the application is going wrong. But from a security point of view, if an attacker starts hacking your site, I guarantee you some of these alerts are going to go off unless they are extremely careful and going really, really slow. You point any automated hacking tool at your site, these alerts are going to be firing all over the place. So that's extremely powerful, and it's pretty much a tick in the box and a few quid a month, okay? The other one, if you use Azure SQL, is this thing called Azure Threat Detection. It's part of the SQL Advanced Data Security package. And what that will do is it will monitor your SQL and again baseline your SQL traffic. And it will tell you if something happens that is not normal. Again, not fixed rules, but based on baselining it automatically. So the ones we get most often is that one about, oh yeah, somebody logged in, they did have a valid username and password, but they don't normally come from, wherever that was, Dublin. They don't normally log in from Dublin. I cannot explain how much that makes me sleep better at night, because if somebody tries to hack my database, I'm going to know about it real quick, because I'm going to get one of these. Okay, manual alerts, I mentioned some of them before. This is where you have to think about your app. What's special about your app? How can you know that something is a bit weird? I mentioned the 404s before. There you go, somebody's probably scanning you. 403s, privilege escalation, failed logins. I mentioned all these before. And also, and this is important for the internal actors, one that we fought with auditors about for years, about how do you know that somebody in your organization started downloading data? How do you know that Bob in accounting, he's allowed to do reports, and he normally downloads 10 records, all of a sudden he's downloading 10,000 records. What's going on? How do you know that? And you can know that with Azure. It requires a little bit more work, but let me, I'll show you how to do that in just a second. So with application insights, all you have to do, you probably can't see that, but you go into application insights. In this case, I'm saying, I just want to write a query that I say, just give me search for request where the response code is 404. I don't even have to think about counting them or anything, because that's all I do. And then I say to Azure, If that number of resolved is more than 5 in any 5-minute period, and please do that every 5 minutes, then give me an alert. And that's it, and then you'll get an email. It's that simple. Alerts in SQL, what you have to do is configure SQL to write every single SQL statement out to log analytics. Which sounds crazy, right? But it works, and it doesn't slow down SQL because it's already logged anyway. So you're hooking into a event pipeline that sits outside of SQL anyway, so there's no performance hit. And then that will allow you to then write alerts. So what I have, quite literally, is a rule that runs once a day, that runs through for the last 24 hours and says, just summarize who has access to what data and how much did they get, who's not the application, and send me an email. And then I get that thing. And therefore, I can show that to the auditor and everybody's happy. Very powerful. And by the way, there's some amazing performance analytics tool that can run once you switch that on as well, by the way. And that will tell you so much deep insight about what goes on. But that's not for this talk. That's another one. Okay. SQL Advanced Data Security is a set of tools they have with threat detection in it. What they will also do is basically do, static code analysis. It's essentially the same thing, but for a database. So they have written like hundreds of best practice rules about what users you have, how much privileges they have, and all sorts of stuff. And they just give you a report to say, this is what you should fix, and then you can tell them, oh, I'll fix that, I don't care about that, and all that stuff, and then you can rerun it and compare, so you have a baseline. So when the auditors come in, you can show them how you're monitoring these kind of things. Again, very helpful. And also, it will also try and scan, not so useful, but it will try and scan for column names to find out which ones might have sensitive data in them. So if you have credit card and NI number, it will tell you these are sensitive, and you should probably consider encrypting them or masking them, which is another tool you can use. So, in closing notes, covered a huge amount of ground today. There are many more tools than this, but hopefully at least I've given you some kind of framework and some ideas about the kind of tools you can use. I wouldn't use all of these tools on any one system in most cases, but there's a bunch of things. I would focus as much on the detection as anyone else because it's easy to do and it gives you a lot of bang for the buck and side benefits as well. Oh, and one more thing on that. If compliance is huge for you, always go for Azure SQL, not Cosmos, because the compliance tools in SQL are light years ahead of Cosmos. In fact, it's really hard to pass a security review with Cosmos, which annoys me because I love Cosmos and I prefer to use it. Like you haven't got users in Cosmos. Auditing is a nightmare. You only have master keys. I mean, well, you have got users, but they only last for 4 hours. Anyway, so just think about that. Pros and cons, right? Questions? I think I've got exactly 3 minutes left for questions. Yay, check me out. Yes, please.
The slides available at all?
Yes, they're all on GitHub. I will, hopefully, I should have recorded this, so that should be available as well, if the recording has worked. But yeah. God, I can't believe you aren't asleep, all of you. Hi.
Hello. What do you do if you detect that somebody's hacking you? So you get an alert, you know that somebody's probably inside your app.
Yeah.
Then what?
Right, sorry, you're right. I skipped that bit. One of the things depending on your risk profile, it is useful to consider preemptively having ways of dealing with that, like blocking IPs on users. Now you can, the simplest thing is to go, if you can figure out their IP address, go into Azure and switch it off. Or if it's a sensitive enough system, the big red button, take the system down. It depends on, but you're right, you should plan for that scenario. That's a very good point. Sorry, but did you?
If you're only using Auth0
Yes.
for authentication, is that sufficient for security or?
Well, don't forget, all that Auth0 or ADB2C will do is handle the password and the username. What they then do, and this is where people really get this wrong, so I'm not picking you here, that passes you a token to say, I've just identified this user, over to you, boss, and 9 times out of 10, you will convert that to your own session token, your own logon session token in a cookie or something else, and that's on you. Auth0 ain't helping you with that in most cases. There are certain cases where they do, but in most cases, it's your problem. And that's where I've gotten bitten by that and thought, oh, that's great, I'll use this other thing and it sorts all my problems out, and then realizing it doesn't. Anyway, yeah?
If I use a Docker container, let's say a Windows Docker container as opposed to a Azure Web App,
Yes.
do things like the concept of VNets and other stuff, do they differ a lot? Or,
I'm not 100% sure. I think that a lot of the VNet stuff you can do. I know that there's an extension, if you're using Kubernetes, for example, on Azure, there's an extension to the Kubernetes definition files that allows you to define things like I want a SQL database and so on as part of the Kubernetes setup, and I believe you can set up the VNets and stuff. But there's also, what's it called, within Kubernetes, there's that plugin you can use to control your network traffic. Istio, that's the one, which is good. It's a good idea to use that, or that can also burn you, as Guy found out, because the IP addresses for Azure SQL are not static, so you've got to be a little bit careful with that.
And also, you also mentioned that the Azure firewall was not very impressive. Is that right? Was that?
It depends on what you mean. You can't configure it, and it is by definition very permissive, right? It's not so. There's a lot of stuff. It's not obvious attacks. It will stop, but I don't know where the threshold is, and I've never had anything blocked by it, right? So, and there's certainly sometimes we do stuff that must look suspicious, but the Azure firewall doesn't do anything about it. So, I wouldn't trust it very much. Not because it's bad, but just because it's configured to be permissible, because it has to be. Anybody else? Right. Thank you very much.